Good morning, dear students. My name is Farhan Mazhar, and the subject today we are studying is Cambridge O-Levels Physics 5054. This video is important for the ATP paper. We call this paper 4 of the O-Levels Physics. You see, in this video, we are going to show you the apparatus which is used in the ATP paper. From where I'm picking these names, the name of the apparatus was given in the syllabus, which was for the examination from 2023 to 2025. So at the end of that syllabus, they have given a list of apparatus. The student must be familiar with this apparatus. So I'm going to show you the name of the apparatus and the photo of that apparatus, and we will try to tell you that for what purpose that apparatus is used. So this video is very useful. Please watch this video carefully and try to remember so that whenever the questions in the ATP come and they use those names, so you are familiar with those names. So let's start. The very first diagram which is shown on this first slide, you can see this experiment is a famous experiment. You can see here we have optical bench, and here we have a convex lens. Here we have another convex lens. Here we have a wide screen. On this a number is written. I think 1 is written on it. Here we have a source of light. So we move the screen, we move these lenses, we move this object, and when a sharp image is formed on the screen, this is your screen. Then we check how much is the distance between the lens and the screen, the object and the screen. So this is a very famous experiment which frequently comes in your ATP paper. So let's start. So let's go to the first slide. From where I'm picking these names, let me show you that list is also important. You can see this is the syllabus, and from there, according to the list which was given, that the student should be familiar with these objects. You can see the journal, adhesive putty, adhesive tape, card, dropping pipette, pair of compass, ruler, S hook, scissors, set squares, string, thread, top pen, electronic balance, tracing paper, wooden boards, and in mechanics we need expendable steel springs, force meter, G clamp, glass ball, marbles, ball bearings, and table tennis ball, half meter rule graduated in millimeters, masses of 10 by 10 gram or 10, I mean the number of, or should be 10 gram or 100 gram, including holders, and meter rule graduated in millimeter, modeling clay, plasticine, we call it, pendulum bob, pivots, nails, triangular wooden blocks, retard stand, boss and clamp, single wheel pulley, and stopwatch. And then you have in thermal physics, we have beaker, glass, and boiling tube, measuring cylinder, and plastic or polystyrene cup, and thermometer. In optics, we need converging lens of this focal length, 10 centimeter focal length, converging lenses of 15 centimeter focal length, diverging lenses, glass of perspex, and the 60-degree prism, glass of perspex, blocks, rectangular and semicircular, optic pins, plane mirror, pin board, protractor. In electricity, we need ammeter, we need voltmeter, we need cells and holders for the cells, connecting leads, crocodile clips, DC power supply, variable to 12 volt, diodes, LEDs, filament lamps, and holders for them, filament lamps of 24 watt and 12 volt, and holders for them, LDRs, and switches, including the push switches. Push switches are those which you push. I will show you the diagram. Selection of resistors, and thermistor with the negative temperature coefficient, and wire constantan, eureka we call that, and wire of nichrome. So these are the apparatuses. So basically what we are going to do, I have collected their diagrams so you can understand them. And let me show you. So here we have the first apparatus is showing up on your screen. So this is adhesive putty. Adhesive putty is simply it's when you put it somewhere, the two things can be joined together. It's like a glue, but it's like a gum, and you can, for example, you put it on a surface, you put that adhesive putty, Patafix, Blu Tack we also call it, and then you put a page on it, the page will stick to that surface. So this is to hold the things, and this is used. Okay, so then the next thing is the adhesive tape. We also call it sellotape. Sellotape, you have seen this, you know, and this is frequently used in our daily life. So sellotape is also used to fix the paper on a board. For example, to paste something, to hold something, we use sellotape, adhesive tape. This frequently they use this word in your ATP paper. Then we have this pipette. The pipette is very important. You see, the pipette has, the pipette has a bulb here, and the bulb, this when you squeeze this bulb, the air will be taken out, and when you release this bulb, the liquid will be sucked in the pipette. So you can, if you want to pick a certain amount of the liquid, certain volume of the liquid with the help of the pipette, you can do that. This is called the dropping pipette. You can also read it from here. So then we have these syringes. These syringes are also used to transfer water or liquid from one place, from one beaker to another. And with the help of the syringes, you can pick up certain amount of liquid from one place, and you can put it into the other beaker. These are called small plastic syringes. Then we have the pair of compasses. The pair of compasses is very important. It is used to draw arcs. It is used to draw perpendiculars. It is used to draw normals, and it can divide a certain angle. It can bisect the angles with the help you have learned in your mathematics, the use of these pair of compasses. Then we have this ruler, which is 30 centimeter long, very important, used to measure the length. Okay. Then we have S hooks. S hooks can be used to hold the things. You can see, if you pay attention to this diagram, you will see that the S hooks are used to hang the things with a rod. So then we have scissors. Scissors are used to cut cards, to cut paper, or cut a pipe, cut a plastic. Okay, so then we have set squares. With the help of the set squares, we can measure 90-degree angle, we can draw perpendiculars, we can make sure with the help of the set square that our vertical scale is perpendicular to the horizontal tables. And the set square is also used to measure the height of the bottom of an object from a vertical scale. Then we have this string. You can see I have shown a diagram here also. This string is used to, and this is here we have a frictionless pulley. This string is attached with this hanging mass, and here we have a string vibrator. So in different experiments, this string is used. Then we have this thread. This thread is attached with the pendulum bob, and the pendulum bob then we can use it as a pendulum. We can measure the time period. So this thread is important. And then we have this top pan electronic balance. Top pan electronic balance is used to measure the mass of an object. So it's very important. A 0.1 gram, it measure up to 0.1 gram. It can display. Easily, because display is digital, so it's easy to read what is the mass. So then we have this. Tracing paper. Tracing paper is used as an object also. Tracing paper is also used as a screen also in the experiments of the light. Okay. Then we have these boards. You can see these boards. This can be used as a ramp, and this can be used as we attached a Newton meter with it, and we pull these boards on this ramp. You can see here we have an experiment. This is a board on which that light experiment, the experiments of the light are there. Here we have holders which are holding a tracing paper. Here we have an object. This tracing paper can also be used as a screen. Here we have a string which is passing over a pulley. This is also a board. Okay, there we have extendable steel springs. This is also, they are all extendable. You can say steel springs. We use them when we are performing the experiments related with the, extension. When we are finding the extension and the load, we're trying to find out we are trying to plot the graph between the extension and the load, and then we use this. The extendable steel springs are also used in the Newton meters. We can see that. And here we have force meter. Force meter is a Newton meter that is used to find out the weight. It is also can be calibrated. This can also be calibrated to measure the mass, but directly it measures the weight of an object, and it also measures how much force is being applied. Force meter, we call this. This is also called Newton meter. Then we have here we have another, and that is a G clamp. G clamp, as you can see, by this help of this screw, we can hold the things with a table. We can hold a board on a table. We can hold anything like this with a table, and then that thing will be no more moving. It will become stable. It will be fixed on the table with the help of the G clamp. Okay, so remember this name, remember this instrument. Okay, then we have this instrument. This is called glass marbles. Remember this name, marbles. They are used. We roll them down on. We roll them down on a ramp. Sometimes we note down how much is the time they have taken to roll down and how much distance they have traveled horizontally. We use these glass marbles. And one very famous experiment is how to find the diameter of the marble. We put marble between two wooden blocks, and then we measure the distance between the inner ends of both the blocks. That tells me how much is the diameter of that marble. A very famous experiment. The glass marbles are used there. These are called ball bearings. These are small steel balls, and they are between these two surfaces. So these ball bearings are used in tires, tires of the cycle, tires of the car, everywhere. Wherever something is rotating about an axis, we put these ball bearings there. This reduces the friction. You should be familiar with this diagram. These are called ball bearings. Then we have tennis ball. Many times this comes in experiments. Tennis ball is dropped and it bounces. You measure how much height it has gained. Sometimes you measure how much time it has taken to to come down. This is called the table tennis balls. And then this half-metre rule. Half-metre rule is like 50 centimeter. And then we have these are the masses, and these masses they might be of 10 gram, they might be of 100 gram, and usually they have a holder with them. This is called the holder. On this holder we put these masses, and we can, for example, you have put 10 gram, then you put another, then it becomes 20 gram, put another, the total mass becomes 30 gram, this way. And normally what we do, we hang them in this holder. The holder is hooked with the thread, and that thread passes over a pulley. And so this is how this is done. You know, so the masses and holders. Okay. So this word is very important. You should be familiar with this word. Okay, then we have this meter rule. This is the big meter rule, which is 100 centimeter long. And this is normally in our physics lab. This is made of wood. Maybe some other materials are also used. and we frequently use these meter rules to measure distances, and they are also used when we put pivot bit under them, and we hang masses on both the sides to find out the moment. To prove the principle of moments, we use this meter rule. Okay, so then we have another, and this is called modeling clay, plasticine. Modeling clay, you all are familiar with. We normally call it clay. The children call it the Play-Doh. With the help of the Play-Doh, we can hold two things together. We can make models with it, and we can, because it's very, easy to handle. You can reshape it, you can reuse it again and again. So this modeling clay is also used in our experiments. Sometimes, maybe you remember in your chemistry, you make the models of atoms, molecules actually. So there they are used to hold the sticks together. Modeling clay is used. Okay, then we have pendulum bobs. The pendulum bobs are hung through by a thread. The pendulum bobs are hung by, we tie a thread with these hooks, and then that thread is held in a clamp, and then a pendulum. So these bobs can swing, and they make a pendulum. Okay, so these pendulum bobs normally they are of the metal, and this thing is called a plumb plumb line. Plumb line is you have a plumb bob, which is normally in the shape of a cone, and a thread is attached with it. And with the help of this, you can make sure that the things are exactly vertical. For example, if you want to make sure that this is a scale and is this vertical, exactly vertical. So what I do, I hold a plumb line with it, then I check the gap between the thread and this scale. If the gap between the thread of the plumb line, when the plumb line is hold like this, and you hold it from the thread and its metal bob is hanging, so that thread is always vertical. So what you do, you check the gap between the thread and the scale. And if the gap between the thread and the scale remains same throughout, that means your scale is also exactly vertical. I can tell you that this plumb line is also used by masons when they are making a wall. So they put bricks, and then they hang a plumb line beside the wall, and they check the gap between the thread and the bricks. If the distance between the thread and the bricks remains same throughout from the top to the bottom, then that means that that wall is exactly vertical. So the same technique is used by the masons who makes walls and in the civil construction, and the same technique we use to make sure that our scales are exactly vertical. Sometimes if something is above in the air and we want to measure the distance of the end of that, so we put a scale on the horizontal table, and then that rod which is in the air, beside its end, we hang a plumb line. And wherever the vertex of that cone comes on that scale which you have put on the horizontal table, that is the distance of that end from some other reference point. So this is how this is used, the plumb line and these pendulum bobs. So they are very important. Then we have these pivots. These pivots, you can see the pivots are can we need nails also, triangular wooden blocks. These are triangular wooden blocks. They are pivots. They are used as pivots. So in those experiments for the moment, the turning effect or the torque, we use them. We take a meter rod, and we place these wooden blocks under it, and then we hang masses with it to prove the principle of moments. So this is pivots. You should remember them. Then we have, this is a very important words, so please check them. This is called a retort. Let me. These are called retort stands. This is the base of the retort stand. This is called clamp, and this which holds these clamps with this iron rod. These are called boss. Clamp, boss, stand, iron rod. This is the iron rod. This is the cross clamp. This is the retort clamp to hold the things in it. And these are retort strings. Sometimes we put here, for example, a flask, you can put a beaker, you can put here. This is the base of the retort stand. So this name is very important, clamp. They use the word clamp to hold the things. Then they, in your paper, they frequently use the word boss. Okay. And retort stand. This whole thing is called retort stand. This is its iron rod. Hopefully you will remember them. And then we have this thing. This is that pulley, which is attached. This is a single wheel pulley, you remember. And the experiments, a thread passes over this pulley, and then here we have that holder, which is attached with that thread. And on that holder we put masses, and on this table we have a weight, a force meter attached with it, and then we have a block attached with it, and we put the masses on these holders, these hangers, and we check how much force is needed to slide those wooden blocks on that horizontal table. So this is that single wheel pulley, and this is how it is attached at the ends of our table. Okay, so this is very important. Then we have stopwatches. The stopwatches can be manual stopwatches. This is that manual. I'm sorry, I said manual. It is analog. This is analog stopwatch. Analog stopwatch is this one. This one is called the digital stopwatch. To read the reading from the digital stopwatch is obviously very easy. And it is also, the analog one is also very easy, but it's sometimes student might get confused, but the digital one is very easy to read. Okay, so then we have this. These are called. These are borosilicate glass beakers. Beakers, glass, borosilicate. He used the word borosilicate. Borosilicate glass beakers are basic beakers with the enamel graduations. They have graduations on them, so you can measure how much volume of the liquid is in them, how much volume of the liquid was before and after you have taken out, or you have put more liquid in it. Now, how much is the volume? So basically, they can tell you how much is the liquid in them. So they are heat resistant. You can put them on a Bunsen burner, and they are also chemical resistant. So we can put some chemicals in them as well. There will be no problem. So a borosilicate beaker. Okay, this is the boiling. This is called the boiling tube. The boiling tube, is you might have seen, you remember that experiment in which we proved that the water is a bad conductor of heat. So there we use this boiling tube. We take this boiling tube, we put water in it, and we keep it tilted a little bit. We hold it in a clamp, and at the top of the this boiling tube, we use a flame, and we boil that water, and we have an ice cube at the end of at the bottom of this boiling tube, and that is kept down there with the help of a metal gauze, and a metal mesh keeps that ice cube at the bottom of this boiling tube, and the water starts boiling at the top, but the ice cube at the bottom of this boiling tube do not melt. That is the experiment, you remember, is that the water is a bad conductor of heat. So there we use that boiling tube. So other materials can also be put in them. uh, for example, you put oil in them, you can heat it, and this is also boiling tube, very important. So okay, so we are going to the next one, and the next one is this one. These are measuring cylinders. Measuring cylinders are graduated. Graduated means, and they are constant diameter, so their diameter throughout them is same. So here we have graduations on them. So with the help of these measuring cylinders, we can measure the volume of the liquid. We can measure how much volume of the liquid we have taken out. We can measure how much the volume of the liquid we have put in. We can make sure that, for example, I have to add a certain amount of volume into a beaker. So I will pour that liquid into this measuring cylinder. I will check what is the volume. Then I will pour it. And the measuring cylinder is always put on. When you want to take the reading from the measuring cylinder, you always put the measuring cylinder on a table, which is exactly horizontal. And so it should be leveled, and then we should use them. If you want to check the level of a table, if you want to make sure that it's exactly horizontal, we use spirit level. So I have made a video in my this ATP physics playlist. You go, you will find there. I have made a separate video on the use of the spirit level. So then we have, after measuring cylinder, we have here, these are polystyrene cups. You should I hope you are familiar with them. These are the cups in which we go when we go to marriages or functions. They put tea in them. Pink tea in Pakistan, very famous. They put pink tea in these cups. We put tea in them, and sometimes these are polystyrene cups. Sometimes they also have lid. You see in the experiments related with the heat, they make this condition that we have a polystyrene cup that has a hot water in it, and there is no cup without lid, they say. And then they have a polystyrene cup in which we have the same hot water, but now we have a lid on it. So you can see these are the lids on them. So we change the conditions for the heat loss or heat gain. So these are polystyrene cups, and they are basically insulators. They keep the thing warm for a long time. So I hope you know them. Okay, then we have this thermometer. The thermometer normally we use in the lab, that goes from, its temperature range is from -10 to 110 degree centigrade. If you look at these diagrams carefully, for especially this one, this is going from -10 to, I think, no, this one is up only going up to 50. So the thermometers are available in the lab. You should be familiar. They are used in the experiments of the heat. Okay. Then, and from there you measure the temperature. So whenever you measure the temperature, you see your line of sight must be perpendicular to the scale to avoid the parallax error. Okay, then we have the convex lenses. The convex lenses are those lenses which are thick in the middle and thin on the sides, and they converge the light on their focal point. And the convex lenses, converging lenses, they can make real images, and they can also make virtual images. You see, when they make real images, the image might be diminished. Diminished means it might be smaller than the object, and with respect to the according to the position of the object, or with respect to the lens, the image can be real, the image can be magnified as well. So this convex lens is very important. One thing very important, that the convex lens makes a focused and sharp image if the object is placed at infinite distance. And when I say converging lens and I say infinite distance, that means an object which is more than 2f distance away from a convex lens. When an object is more than 2f distance from the convex lens, its image is formed on its principal focus. Okay, that's why you remember that experiment in which we have a window in the wall, and we take a scale, we put it with the wall, opposite wall, and on the scale we move a convex lens forward, backward, and when we get a sharp image of the window in the opposite wall, on this wall, then the distance between the lens and the wall when the image is sharp is equals to the focal length. So what is the theory behind it is that the object, which is that window, which is in the opposite wall, and that window is at a distance of more than 2f. That window, the object is at a distance of infinity. So its image will be formed on that screen at the principal focus of that convex lens. So that is how you estimate the focal length of a convex lens. You see, the convex lens can also be used to make the virtual image. And this happens when a virtual image is formed. The virtual image is formed when we use the convex lens as a magnifying glass. And when the virtual image is formed by a convex lens or converging lens, when the object is inside its focal length. If you place an object inside the focal length of a convex lens, the lens will form a virtual, magnified, and upright, erect image of that object. So whenever you use converging lens as a magnifying glass, the object is brought very close to the converging lens. Actually, what is the theory behind it? That you bring that object inside the focal length, and then the virtual, magnified, and upright image is formed. Okay, so you should be familiar with this word, its uses. Then we have this concave lens. In the concave lens is that lens in which we have you see, a concave lens is that lens in which the middle of the body is, thin, and the ends are thick. That is called a diverging lens or a concave lens, and that when the light passes through it, it diverges the light. And when it diverges the light spreads out after passing through the lens. And it appears that it is when you look from the other side, it feels that they are coming from that F on the other side. Okay, so the light diverges. So these are different kinds of lenses. You should be familiar with them. Okay, then we have this prism. You must have seen this prism. When the white light passes through the prism, what happens? The white light makes a spectrum. It makes a band of colors, and the code word is Roy G. Biv, and this is called the dispersion of light. So if you use a laser beam, we can trace the path of that light uh, in the prism. We place the prism on a paper and we pass the light through it. We put dots on the paper on the incident ray and the emergent ray, and the point where it enters the prism and point where it emerges. And we join these 2 points after removing everything. And this is how you trace the path of the light inside the prism. So this is very, very important. And all these angles here are of 60 degrees. Okay, then this is the glass perspex. You remember this? These are perspex. They use sometimes your paper. They use this word only perspex. They do not use the word glass. Perspex is a type of glass. So these are that rectangular glass blocks, and where you have seen them when you have studied the experiments, when you have performed the experiments of a refraction of the light. And there you have in your textbook you have seen these rectangular glass blocks. You see, sometimes I use a source of light, for example, a torch, a laser, to show you the incident ray and the emergent ray and the refracted ray here. Sometimes we put pins here, and we look from if I put 2 pins here, then I come here on this side and I saw the image of those pins, and I put pin 3 and pin 4 here. I hope you remember that experiment. So this glass or perspex blocks are used there. So, and then here we go. This is very important. This is also a glass, but this is a semicircular and glass block. And where you have read about them in your textbook, where you have studied total internal reflection, and you remember that. I hope you remember that experiment. Here you can see we have this is called a ray box, and a ray of light is coming from it. It is passing through this semicircular glass block, and sometimes we use a paper which has already angles marked on it. So what we do, we move this ray box to the right, to the left, and we observe what happens with this emergent ray. So remember this name, semicircular perspex blocks or semicircular glass blocks. You should remember them. You should be familiar with them. Okay. Then we have these optical pins. If you have performed the experiments of the reflection or refraction of the light in the glass blocks or in a plane mirror, you use these pins. You use these optical pins. You see, these are the optical pins. We can put those pins on the incident ray. We can put those pins on the reflected ray. We can put those pins on the emergent ray. And they are used in the light, the experiments of the light, where we observe reflection, refraction, total internal reflection. So these are the optical pins. Then we have here, we have a plane mirror. This is a simple mirror, but its surface is plane. So it's a plane mirror, a normal mirror, okay? And these wooden blocks, these are the holders, and in these holders we have slits. These are wooden holders, they have slits in them. So if you put the like you can see here, they have put that plane mirror into that slit. So now this plane mirror can be held vertical on a paper, and it will not fall, it will not move, it will not move accidentally. Okay, so holder of that plane mirror and the plane mirror. So it is very important. And where you have read about it, when you are proving the laws of reflection, there you have seen in your book these things. Okay, here we have a pin board. A pin board is a soft, it is very soft. The wood is very soft, and you can see these pins can enter into them. The optical pins can enter into it. Here you can see this is a pin board, and on this I have fixed a paper. Here we have a plane mirror. Here that they are doing that experiment of that laws of reflection. So here these optical pins have been, so the pin board is little soft, okay? So easily the pin can penetrate in it, and the pin can be held stable and steady in it, okay? So, and easily it can come out. So that's the benefit of using the pin board. Okay, here we have a protractor. Protractor is used to measure the angles. And these protectors, with the help of the protectors, they are used to measure the angle of incidence, angle of reflection. They are used to measure the angle of incidence and angle of refraction. They are also used to measure the critical angle. So we use them when we use a torch, or we use pins in the experiments of light. So this is semicircular. Here we have the angle from 0 to 180, but this one is a protector with the 360 degrees on it. So they frequently are used. They are also used to measure the angle of the ramp. You can use them to measure this one especially can be used to measure what is the angle of the ramp with the horizontal. Okay, so there they are also used, the protectors. Okay, then we have here we have an ammeter. Ammeter is always connected in series with any appliance or resistor or anything through which you want to measure the current. So the ammeter is always connected in series with it. So for example, here we have a load with in series, the ammeter is connected with it. Okay, here we have a digital ammeter, here we have analog ammeter, and in the when you are using this analog one, you should be careful because there can be parallax error, there can be zero error. You know what is the meaning of zero error? Zero error means that this pointer, you have not attached anything, but it is still showing some reading. Or it must be on zero exactly. If it is not, then it has zero error in it. Okay. Then when you are measuring from it, when you're taking reading from the ammeter, you should avoid parallax error. How you avoid parallax error? Your line of sight must be perpendicular to this pointer and the scale. So this is ammeter used to measure the amount of current passing through. Okay, so here we have a voltmeter. Here we have multimeter also. And multimeter can be used to measure the multimeter can act like a voltmeter. It can also act like a ammeter. It can also measure resistance. Okay, here we have an analog voltmeter. Analog voltmeter can tell you the voltage drop across a resistor, across a thermistor, across a diode, across anything. The voltmeter is always connected parallel to the device. Okay, so for example, if you want to measure what is the voltage drop across a lamp, so the voltmeter will be connected parallel to that lamp. Okay, then we have these, frequently this is used. We have cells, battery cells, and we have holders. We have, you have seen these holders in your remote controls, in your toys, and they are also available in the physics lab. Here too, if you put two cells, that they will be connected in series with each other. When you put the cells like this, their EMF is increased. For example, here 1.5, 1.5, 1.5, 1, so they have connected the cells in series. You can see there. So you are getting their EMF of the combination has become 6 volt. So here we have the holders for the cells and the cells themselves. So batteries, cells, okay. Here we have connecting leads, connecting leads. Here we have connecting leads. So you must have seen these are used to connect the two wires with each other, electric wires. I mean, there we have connectors. Connectors have a male and a female. So the male is entered into the female, and you must have seen them in your physics lab. Here we have the crocodile clips. This is a very famous name. Where you have seen crocodile clips, I can remind you, you have seen it in your daily life. You know, if you look at the battery of your car or battery of your UPS, so you will find these crocodile clips. So they are attached with the terminals of the battery. These are crocodile clips. And with these crocodile clips, you can see these are crocodile clips. This is their enlarged photo. So these crocodile clips have wires behind them. Okay, so here we have wire behind them. So these crocodile clips, they can be attached on a wire, especially, you know, that experiment in which we find the resistance of a wire, a certain length of a wire. So we use a crocodile clip. So one crocodile clip is attached at the start of the wire, then the other crocodile clip, let's say I put on 10 centimeter, then I move that crocodile clip on 10, 20 centimeter, then I move that crocodile clip to 30 centimeter. So these crocodile clips easily they can electrically be attached to a cable, to a wire easily. So remember these crocodile clips, they are for electric, whenever you're doing experiments related with electricity. So they are used. Okay. So this is very important. Here we have a power supply of DC power supply. It's a variable power supply, and that these frequently then experiments they say variable power supply. So the basic benefit of using the variable power supply is that you can vary or you can change the voltage, you can change the EMF which you are providing to a circuit. So for example, you can increase the voltage from, let's say, first of all, I put that voltage to 1 volt, then I can make it 2 volt, then I can make it 3 volt, then I can make it 4 volt, then I can make it 6 volt. So you can change the volt. And there is a certain, obviously, maximum voltage which this power supply can provide. So it's very easy. So this is a variable power supply, and this one is DC power supply. So this is frequently they use this word in your experiment. This is diodes and LEDs. You know, the diodes, in the diode you see what happens. This is a diode, and diode let the current flow in one direction. If the conventional current is in the direction of the arrow of the diode, it will let the current flow through it. But if the conventional current is opposite to the arrow of the diode do not let the current flow through it. So the diode resistance depends upon the direction of the current. If the direction of the conventional current through the diode is according to its arrow, along its arrow, then its resistance is low. But if the current's direction, conventional current's direction is opposite to the direction of the arrow of the diode, so then its resistance becomes very high. Okay. Then this is another thing is this is LED. LED is a diode. When the current flows through it, it emits light. So you have seen everywhere LED lamps. Everywhere we have those. So when the light passes through them, they give out light. So they are called LEDs, and their electrical symbol is very important. Sometimes in your paper, they ask you to draw the symbol of diode. Sometimes they ask you to do the symbol of LED, light emitting diode. Okay, so remember these symbols and their function also. Then we have these, here we have bulbs, filament lamps, and their holders. So the lamp is always in a holder. So these are the holders, and this is the lamp and this is the holder. And why I call it filament lamp? Because here we have a tungsten wire, and when the current flows through this, that tungsten wire becomes hot, it becomes bright, it gives out light. Okay, so it gives out heat also, and it gives out a lot of light also. So this is called a filament lamp. And you know the filament lamp is a non-ohmic conductor. So its IV graph, voltage and current graph, is not a straight line. It is always a curve, which means that the current and the voltage, they are not directly proportional to each other. So it do not obey Ohm's law. So that's why we call it non-ohmic. So remember this name, filament lamps, their holders. Okay, here we have the filament lamps with more power, 24 watt, 12 volt, and their holders. Okay, so then, so this is very important. Okay, then we have here, these are called LDRs, light dependent resistors. Okay, sorry. So these are the light dependent. This is the shape of the light dependent. You must have seen these on the circuits. These are light dependent resistors. When the light fall on them, their resistance becomes low. When there is dark conditions, their resistance becomes high. And their electrical symbol for the ATP paper, you should know what happens with the resistance. You should also know that what is their electrical symbol. So because sometimes they will ask you to draw the circuit symbol for the LDRs, light dependent resistor. So this is the LDRs electrical symbol. Okay, then we are going to this. These are the switches. You can have these kind of, we have these toggles, and let me stop it. Okay, these are the toggles. Okay, so you can switch on off to cut off the supply of the current. And these are push button switches. You must have seen, you push this button, the current is gone. Means the switch is open, you push it and the switch is closed. I mean the circuit is closed. So you have seen, I think, in their daily life, these push button switches and push switches, we call them. And this kind of switches also you have seen in your some old vintage cars. You can see these switches. And in Pakistan, in very old switches were like this, we use in our homes. Okay, so this is a very important diagram. Remember, these are resistors. So the function of the resistors is to convert the electric energy into heat. And why we use them in a circuit? To reduce the voltage which is being supplied to another appliance, or to reduce the amount of current going to another appliance. So They are used in the circuit to control the voltage and to control the current going into, for example, a lamp or a motor. You see, if the power rating, this is a very important fact. I learned it from an electric engineer. You see, as the power of the resistor will increase, the size of the resistor will also increase. It's a fact. So the resistors who have less power rating, their size is small. And the resistors who have larger power rating, their size is dimensions, length, width, height, thickness. That is also larger. So if at some place you all of a sudden decide to use a larger power resistor, then this slot on the circuit board that might become smaller because the size of the larger power resistor is larger as well. Dimensions are bigger. Okay. So the resistors are used in the circuits, and you should know their electrical symbol. Okay, then we have these, and these are called thermistors. These are negative temperature coefficient thermistors. That is in our syllabus. Thermistors, this is their electrical symbol. This is the electrical symbol which we use in our syllabus, and this is the American symbol. We use this one in our syllabus. So here you have a resistor, and then you have a hockey, ice hockey on it. So I call this ice hockey. So this is thermistor. What happens with the thermistor? What happens if the temperature of the surrounding increases? The thermistor's temperature increases, its resistance becomes low. And when the conditions become cold, the temperature drops, its resistance becomes high. So that's thermistor. Okay. So then we have this thing. This is called wire constantan, Eureka wire, and the Eureka wire is a simple wire, and this is used to this is very strong, and it is used to hold the things. Okay. Then we have this wire, nichrome wire. Its resistance. This is also an electric wire, and its resistance is very high. So when the current flows through this nichrome wire, its resistance is very high. What happens? Heat is produced. Nichrome wire, its resistance is high. So when the light, when the electricity passes through it, the heat is produced in it. So that's it. These are the names which were given uh, in your okay. So I am back to the first slide. So, my dear students, we are done with this. You see, what was this? This is a video which is related with the names of the apparatus, which was given in a list with the syllabus for the Cambridge O-levels physics for the examination from 2023 to 2025. So I have shown you the diagrams of those that apparatus, and I have also tried to tell you that how we use them. So you are familiar with these words, these names. So when they come in your paper, you have a little bit idea that how to use them. So hopefully, I think that this video will be helpful to you. If you find this video interesting and useful, please like this video. Please subscribe to my channel. Please share the link of this video with your class fellows, with your teachers, with your junior students. Share the link of this video on your WhatsApp groups. Share the link of this video on your Facebook account. Share the link of this video on your Google Classrooms with your class fellows. Share the link of this video on TikTok. Share the link of this video on your Instagram. When you do this, you help me to promote my channel. Thank you very much, everyone. God bless you all. And because now the time I'm making this video right now, and tomorrow morning is the ATP paper for the 2024 May-June exam. Good luck to all my students, and may God help you. May God bless you. May God answer all the prayers of your prayers, your parents' prayers, and your teachers' prayer. The basic aim of these videos is to make the life of students around the globe little easier, their parents' life little easier, and their teachers' life a little easier. I'm not an expert on the physics. I'm just a humble student of physics. If I made some mistake, please forgive that. Thank you very much. Have a good day. God bless you. And once again, good luck for your ATP paper.